this off and you can light the wick, and then you can put that back on, and it would make a nice flame. But you still couldn't see it from a long ways away, because the light goes out this way and it goes out that way, it goes out everywhere except straight ways. And there was a French guy. He wasn't a physicist. He wasn't a person that studied much of anything, except he had this brilliant idea. He said, I know how I can make light bend and go the way I want it to. Because he'd looked at things like pieces of glass with curves on them. And if you take a big curved piece of glass like that, which is a magnifying glass, and you put a candle or any kind of a flame behind it, the light can be focused so that it looks more like a straight beam rather than one that just spreads everywhere. This is one of his lenses. Okay. Is my head right side up? Yeah. How can I make my head upside down?
Turn it around.
Okay. There. Now it's my head upside
Flip
down.
it over. Flip it over.
Flip it over. Okay. Upside down head? No. How can I make my head upside down?
If you bend your
I
head.
could bend my head and it'll be upside down. There's another way to do it though. And they were busy playing out there in the grass. And all of a sudden there was an earthquake. Kaboom, kaboom, kaboom. And they heard thunder. To their ears they couldn't understand what this was. And a huge shadow came across the land. And then something, well they didn't know what it was, something huge came down and crushed a whole bunch of grass and went away. It was a Ninian footprint. And Jack and Jill said, oh no, that big thing, whatever it is, must be evil Mr. Fred's castle. And we're tiny, and they could step on us and not even know it. We'd just be squished on the ground. And the first experiment is going to be with ordinary magnifying glasses, so that everybody gets a magnifying lens. When you get a magnifying lens, you can of course look at your fingers and stuff and see how much they magnify. But then look at your neighbor and see how your neighbor changes when you move your lenses closer or further from each other and closer and further from your own eyes.
It's not the same. Oh! I can see your fingers upside down. Your head is upside down.
We're going to see if we can burn the brick with a propane torch.
I know this.
Is it melting the brick?
Yes.
Do you see the brick dripping?
No.
Is it forming a hole in the brick?
Yes.
Do you see the hole in the brick?
No.
So it's not forming a hole in the brick.
Thing
What's a bigger flame than this?
Sun.
Ah, the sun.
So far, the only people who really got this before
Oh, it's like the sun. It's just my colors getting down.
Just lift up your goggles and you can see what we're going to burn. First thing is a piece of wood.
I can.
Okay, then you can flip your goggles back down. And can you see the bright spot from where you are?
Yeah.
Okay, we'll put the wood where the bright spot is, right there.
Yeah,
And now you can see the other side is all black. Burned all the way through the chunk of wood. There's our marshmallow.
You see it, guys? It blows.
Now, the marshmallow, is it all burned and exploded, or is it
Maybe on
just...
the other side.
The other side was near the brick.
It's crispy.
Surprise.
It's crispy. It's crispy.
The side the sun was shining on isn't burnt, is it?
Can I use a new marshmallow and we got flames in a second?
The marshmallow is so white it reflects most of the sunlight. The side facing the brick is all burned. Because the brick was so hot, it gave off infrared light and toasted the marshmallow from the backside.